All right, welcome for the fourth week. Just gonna wait 2 more minutes before I get started. But let me just make sure that my video is in fact live streaming right now. Okay, looks like it's working. Yeah, I guess we can start 2 minutes early. Let's see here. Problems. We'll probably just do another medium today. I should probably do a hard one of these days, but I just don't feel like Leetcode hard questions get asked that often. Or maybe that's just my experience. I haven't seen them get asked much often. Alright, let's just sort by frequency so that I mean, here's the thing. Whenever I see a lot of these problems, I have done some just because I've done so many interview practice problems and so many interviews, I feel like I've seen a variation of this over the years. So I will just, like the kth largest element in an array. I actually wonder how that's a medium. That doesn't sound too difficult, but I'll skip that because I've done k most frequent before. Let's do this one because I've seen variations of number of islands. I'm guessing, yeah, that's what I thought. I was asked once in an interview, they called it number of continents, and then there was another variation of this that I was asked at a well, there's so many of them. Let's call it. I was asked one of these at one of the self-driving car startups, which was, instead of doing ones and zeros, a grid of ones and zeros, it was a grid of zeros and different integers, and it was kind of a twist on some sort of problem that's based on a graph that's represented as a 2D grid. So let's do this, and I have a feeling I should be able to solve this. So it might be another short video, but then I can kind of discuss what I've been asked in the past that are variations of this question and how I solve those. Alright, so without further ado, let's get started. I'll just read the question again to make sure this is what I think it is. Let's expand this so I can actually see this. There you go. Given a 2D grid map of ones and zeros, where when 1 is land and 0 is water, count the number of islands. An island is surrounded by water and is formed by connected adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Okay, so anytime there's a graph question, I will usually do a form of BFS or DFS. I think the idea here is, so let's draw one of the examples that they have here. And then they have 1 1 0 1 0, and then 1 1 0 0 0 0 0 0 0 0, right? And then let's pick another color ink so I can kind of show. So the number of islands here is 1, because we're saying land can be adjacent either horizontally or vertically. So this is vertical, and they can also be horizontal. So the reason this is 1 island is because these two are connected, these two are connected, these two are connected, these two, these two, these two, these two, and also these. So together they form one island, which kind of makes sense. So the output, obviously, for this one is 1. So let's try another one, another example. So the other example they have is 1 1 0 0 0 1 1 0 0 0 0 1 0 0, and then they have 0 0 0 1 1. So over here, let's try to figure out what these islands should be. So these are connected, so this should be one island. These aren't connected because they did say that only horizontal or vertically adjacent tiles can be considered adjacent. So which basically means that this is an island of its own because there's no link here, and then this one is an island. So I'm guessing the output is 3. Yeah. Okay. So there are a couple of things that we need to keep track of here. The first one is what we're going to try to do is anytime I see a 1, I'm going to do a breadth first search or a depth first search to find out all the other adjacent land tiles to it, and then I'm going to mark them as visited, and then I'm going to increment the total number of island counter that I have by 1. So my logic is going to be, I'm going to go here, and then I'm going to see, okay, because this is a 1, I'm going to try to explore all the other ones that are adjacent to it, and then mark them as visited, and then I'm going to increment my counter by 1. And then I'm going to go here, and because this is visited, I'm not going to do my depth first or breadth first search again to mark its adjacent neighbors. So if I don't mark them as visited, that's the problem. Then I'll come here and I'll say, okay, there's one island here. And then I'll come here and I have no way of knowing if I've already visited this as a part of another island or not. So that's why having that visited array is important. And then when I get here, this is 0. So anytime I see a 0, if it's water, I just ignore it. So this I know is visited, this I know is visited, ignore, 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 ignore. And then this I know is a 1 and I haven't visited it. And then a depth first or breadth first search essentially yields that this is the only thing that should be marked as visited. And then same logic applies for the rest of it. So let's just go ahead and implement that. Okay, so oh, this is an interesting trick. So anytime I get the sense that it is a 2D grid graph traversal sort of question, it is always helpful to just write the in-grid function. And I'll talk a little bit about what I mean by that. So in my book, the in-grid function is a function that takes in the board, okay, and then it takes in a coordinate x and a coordinate y, and then it can tell you whether this coordinate is out of bounds of the board. So if you have this function written, it becomes really easy to write some of the logic later instead of duplicating it. So, and this can just be a one-liner where return x is greater than equal to, why am I writing like it's a math equation? Let's just write it's greater than -1 and x is less than length of board, and y is greater than -1 and y is less than length of board x. Okay, so I think that's pretty straightforward, where x kind of corresponds to the traditional traditional I and j. You can think of them as those two. Okay, so we have this thing written, and we'll probably need to use that later. So what else is there to write? Let us write the basic logic of how we're going to traverse the grid. So number of islands, guessing that's what the function looks like. Yeah, number of islands, and it takes in a grid. Okay. And then, okay, so what do I want to do here? I want to create an array visited. Let's say I've written a function called create visited that takes in a grid and kind of makes a copy of that grid, the same dimensions, but everything is, it's basically a Boolean array. So we can just call it zeros and ones. So everything is by default 0, where 0 denotes that that tile hasn't been visited yet, and then 1 would denote that it has. And then let's assume that I've written that function. I'll come back to that later, because I think in the larger context of this question, that's a little trivial. And then what I want to do is, so let's leave some space. Okay, so of course we want to count how many islands we've seen, so let's keep a counter for that. And let's leave some space just in case we make any mistakes. So for I in length grid, for j in length grid I. Okay, so what's my logic going to be? If grid I j equals to 1, which means it is land, then I'm going to say, let's assume we have a function called mark as visited, and it takes in the grid, takes in I, takes in j, and takes in the visited 2D grid that I created over here. And then that is going to be sort of the meat of our logic here. And then at the end, we just say return num. And then every time we mark as visited, we also increment the number plus equals to 1. Okay? So that's going to be my higher level logic. So we know we have two functions that we still need to implement, which is create visited and mark as visited. Okay? So let us move on to implementing those. Okay. All right, so Jason said, could you discuss modifying the grid versus read-only grid approaches? That is a good question. So let's think about it for a second. How would we do a so I guess in Jason's in the question that Jason poses, I'm doing a read-only because I'm only reading from the original grid, and I've created a new grid which is kind of a copy. So I'm using, in my solution, I'll be using O of n space, or I guess O of n square if you think about it as 2D. If I didn't want to use a yeah, I guess it didn't occur to me because I mean, I think Jason raises a good point here, because I think if that is something that an interviewer wants out of you, they will probably say, can you think of a way to reduce the space complexity? So I think Jason here, he kind of outright gave me what I would have to do to reduce the space complexity. And I think ideally I should have thought of this and kind of discussed this as I solved the problem. I think if we wanted, I guess modifying the grid would be the modifying the grid would probably will be the clever way to do it, because I'm trying to think if there is anything that would cause a problem for us. But I don't think that's going to be true, because, and I think, let's talk about that after I finish this problem. I think that'll be a good thing to follow up on, and we'll talk about this. For now, let me finish up my current logic here. So let's implement mark as visited real quick, because that is sort of the more important function that we have. So it takes in a grid, it takes in an I, it takes in a j, and then it takes in the visited. So what we want to do is we want to say visited I j equals to 1. So here's something I noticed right now. I've made a mistake here. I only check, so let's see over here. I only check if my current the current tile is land, but I am not leveraging the visited grid. I'm not checking if I visited this already before. So that's important. That's the whole reason we had that visited grid. So let's fix that real quick. To be honest, this is kind of redundant, because we can check the truthiness of this just by writing that much. If grid j and visited and not visited, right? Because we want to make sure that the tile hasn't been visited yet. Okay, so then we set inside, let's come back to mark as visited. We set the visited ij equals to 1, and then we say for xy in what are the different things? So I could go I plus 1j, I could go I minus 1j, I could go j plus 1, sorry, I could go I j plus 1, and then I could go I j minus 1. So those are the 4 places I can go, right? Because the only ways I'm allowed to go is vertical and horizontal. Then I'll say if in grid x, y, then also mark these as visited recursively. So I'm taking a DFS approach here. And then this function doesn't return anything, because all this function's job is to make sure that we mark all the adjacent islands of ij as visited. Okay? And then we can quickly write our create visited function that copies the grid. So what we can say is this initializes a visited equals to just an empty list, and then for I in length grid visited dot append append okay. So basically I am making an array of zeros equal to the length of grid of the ith index. So this way, even if the map is not a perfect square, which is in the case of the example inputs, your code should still work. Alright, that's it. So I think our code is pretty sound, but I mean, I would still, at this point, run this through a few test cases. I'm not going to do that just because I want to quickly talk about what Jason was saying, which is how would we solve this without using that extra memory for visited. So let's think about it. Actually, it's not that complicated because I don't think there's any point of rewriting this because I could change a few lines here and do that. So I would simply remove this line, and then over here I would add a line that says grid I j equals to 0. That's it. Simple as that. Yeah. I think that should take care of doing this in memory. I don't know if Jason is online anymore, but because if you think about it, if I'm here and I go here and I say for I plus 1j if in grid, so this is an in grid, this is an in grid, this is in grid, and this is in grid. So I go here, this is an in grid, this is an in grid, and then this. That's the problem. I guess that wouldn't solve it because when I go here, I'll try to go back here and this is still marked as 1. No, I just realized there's an obvious bug here that I completely missed, which is should be and grid xy. I mean, if it's not 1, why would we even visit? Okay, so now that we've taken care of that, Jason's asking, what are you stream this? Just OBS or something else as well? I'm using this app called DUX Recorder, I think it's called. Yeah. Then actually the not visited wouldn't be required anymore. So I would just say, yeah, I think that'll take care of our problem. Because in that case, because I only want to traverse things if they're explicitly 1, I'll traverse this, I'll mark this as 2, traverse this, I'll mark this as 2, traverse this, mark this as 2. When this goes here, it will want to go there, but for you to know, you should say that, okay, in that case, I would use BFS. And BFS, to be honest, shouldn't be too difficult. The reason I always go for DFS in the start is because in an in my head, DFS for me is easier to think about. It's not a lot of work to change it to BFS later. And sometimes it's easier for me to think of problems recursively, and just at that point I'm thinking I just want to get a solution on the board before I go and improve it. So I can still have a conversation with the interviewer and convince them just through words or by code if necessary that I could do this using breadth first search if I had enough time and I wasn't under pressure. But I think the most important thing is to just get some working code and a working solution on the board, and we can kind of take care of the nice touches later on. Cool. So I've been asked, so I was going to say, I've been asked a few variations of this question. So at a self-driving car company, I was asked, like, it's a board of 1, 2, 4, 9, so it's just random values. And imagining that we can only traverse to places, like imagining that I'm a camera and I can only see things that are at my level or below my level. So at each point, how many of these tiles can I see? Not necessarily number of islands per se, but more like number of tiles in islands, which is not that different. The underlying idea is the same. Then I had another problem where the tiles in the grid signified different heights of a street, and if I was on a luge and I wanted to go down the street, then what are the tiles that I could go to, which is again only tiles that are shorter than me. So sort of like that. I mean, the underlying idea for all of these are the same, which is some sort of graph traversal, but people ask these with different twists on them. So I highly recommend knowing how to solve these 2D grid